In the discussions of the quantum mechanics in lecture 12, I shall try to explain the particle in 3D box, and it is a part 3. Schrödinger, this is the system. It is a rectangular box where the particle of mass m is moving in all the 3 independent directions, and this rectangular box has the side length Lx, Ly, Lz along this x, y and z directions. This side, and the potential energy within the box equal to 0 and outside the box equal to infinity. As we have shown earlier, this Schrödinger equation for the system, it is del square psi plus 2m h cross square e minus v psi equal to 0. Actually, I have shown the particle in one-dimensional box is very much useful to explain the motions of this electron in atoms and molecules. As for example, one beautiful result I have shown for the spectra of this butadiene. The experimental result and the theoretical result calculated on the basis of this simple model are found to be almost exact. But the motions of this electron in atoms and molecules, they are three-dimensional. So the particle in three-dimensional box will be more appropriate for those cases. So this is why this system is more important than particle in 1D box. And the Schrödinger equation is like that for the system. And the outside of this box, v equal to infinity, and so del square means it is the Laplacian operator we all know, and psi plus 2mh cross square e minus infinity psi equal to 0, or as I have shown earlier, this is in the last lecture, psi equal to 0. So this when inside the box v equal to 0. So whenever we are transferring the Schrödinger equation for inside this box, I have del square del 2 by del x square plus del 2 by del y square plus del 2 by del z square into psi, and 2m mass of this particle and this energy and h cross square, h is the Planck's reduced constant, and psi equal to 0. Here actually this v equal to here 0. So this is 2m h cross square e and h cross square, 2m e by h cross square into psi. This psi wave function is a function of x, y, z. It depends on x, y, z independently, and so we can write this x plus y. X is a function of x, y is a function of y, z is a function of z. In brief, we can write psi equal to x, y, z. And this energy of this box will also be similarly Ex plus Ey plus Ez. It is along this x-axis, it is along this y-axis, it is along this z-axis. So actually, since the operator consisting of these 3 independent parts, so it is wise, it is possible and here also x, y, z, they are also independent to each other. So better to separate this equation into 3 equations, one for each particle in one direction. So this is this one x, y, z, and this one is twice pi e by h cross into x, y, z equal to 0. So whenever we are differentiating x with respect to x, yz remains constant as they are independent. So yz and double differentiation of x with x, and in this case xz is constant and del 2y by del y square. Y is the variable and this y is the function. Capital Y is the function and small y is the variable. Plus here also xy remains constant and del 2z by del z square. Plus 2m, and E is again split up in three directions, Ex plus Ey plus Ez divided by h cross square into xyz equal to 2. So dividing by xyz, in order to separate these three independent equations, it will be 1 by x and d2x by dx square plus 2mex by h cross square, as it is independent and consisting of one variable. So del is replaced by d. And the second part, the 1 by y d2y by dy square plus 2mey by h cross square, and plus this last part 1 by z d2z by dz square plus 2mez by h cross square equal to 0. So this one and this one and this one, these are the three independent terms, and sum of the three independent terms is equal to 0. So it is quite natural, then it would be possible only when each term would be separately equal to 0. So separating this equation, we have this one equal to 0, twice mex, and this term also 0, and this term also 0. So this equation can be written as this one x to be multiplied. So this one x here, and similarly other equations along this y directions and along the z directions are this d2y by dy square plus 2mey by h cross square y equal to 0, and this one d2z by dz square plus 2mez h cross square into z function equal to 0. So each equation is like the particle in 1D box along this x direction, along the y direction, along the z direction, so it is similar boundary conditions. In this case, the boundary conditions 0 to Lx, in this case boundary directions in 0 to Ly, and in this direction 0 to Lz. So whenever we are solving this one, this function will be root over 2 by Lx sin nx pi x by Lx. Nx is the quantum number for this particle along this x direction. And y equal to similar fashion 2 by Ly sin ny pi by Ly, and z equal to this is similar. So this psi, which is a product of x, y, z, we can write here this psi equal to root over of 8, root over 2, root over 8 divided by Lx, Ly, and z, and sin nx into nx pi divided by Lx x, sin ny pi by Ly into y, sin nz pi divided by az into z. So it is saying that to describe this wave function for this 3D motions, for the particle in 3D motions, three quantum numbers are required. One is along this x directions, along the y direction, along the z directions, and all these quantum numbers will have the values 1, 2, 3, 4, etc. any positive integer excluding 0, as we have shown earlier. The energy is also Ex plus Ey plus Ez equal to nx square by Lx square plus Ly square Ny square by Ly square plus Nz square by Lz square into y square h cross square divided by twice n. For the motions of this particle in 3D rectangular box, the wave functions could be written as in a better way psi nx, ny, nz. These are the quantum numbers along this x, y, z directions, and it is a function of x, y, z, this function, and it will be root over 8 by Lx, Ly, Lz, and sin Lx pi by Lx x, sin Ny pi by Ly y, sin Nz pi by Lz into z. And the energy value also could be written as E, Nx, Ny, Nz. These are the quantum numbers given to this energy term. And it is Nx square by Lx square plus Ny square by Ly square plus Nz square by Lz square into H square divided by 8 and L square when H cross is replaced by H by 2 pi. Now we shall start one very important concept of degeneracy. If we consider the cubical box, then this concept of degeneracy will come up. For this cubical box, Lx, Ly, Lz all are equal, and let each will be this L. And in that case, the wave function psi nx, ny, nz, x, y, z equal to, it is L 8 root over 8 by L cube into sin n pi nx pi by L x, sin ny pi y by L, and sin nz pi z by L. And this energy value also will be nx square plus ny square plus nz square into h square by 8 L square. So the lowest energy value, which is called the 0-point energy, can be obtained by putting this value of nx, ny, nz each equal to 1. So in this case, this E111 and equal to 3h square divided by 8L square. And sin 111 equal to over 8 by L cube sin pi x by L, sin pi y by L, and sin pi z by L. And for the next hard state, we shall have to change one quantum number. Say one quantum number is equal to 2 and the other two each will be equal to 1. In this case, the wave functions, there will be 3 states, each having this wave function psi 211, psi 121, and psi 112. But the energy of these 3 wave functions, will be the same as E equal to EU 211 or E121 or E112, and this each are equal, and this energy equal to 6h square divided by 8h square, as any one of these 3 is 2 and the others 2 equal to 1. This type of energy level having more than one wave functions, but having the same energy value is called the degenerate. That energy level is called the degenerate energy level, and this phenomena we call the degeneracy. And if the degeneracy will be lifted easily if we change this length of this cubical box slightly, then the degeneracy will be lifted out. Say L is changed along this x-axis by slightly as L plus del x del L. L plus L plus del L, then energy of these three will no longer becomes equal and degeneracy is removed. This is high. These three, the wave energy levels and their corresponding wave functions, I can show in a table, and this table is energy levels. Here I am showing the energy levels of a particle in a cubical box, and this is energy increasing along these directions. And psi 1 it is the ground wave function, ground state wave functions, and E11 this is 0 point energy 3 h square divided by 8 ml square, and this is non-degenerate, means this level is having a particular only one wave functions. But whenever we are lifting to this next hard excited state, then psi 211, psi 121, psi 112, these are the three wave functions, three states representing three wave functions, but the energy level is equal to, in all the three cases, will be equal to 6a square divided by 8a square. So this is threefold, this level is a threefold degenerate. Whenever we are going to this one, psi 221 and psi 212, psi 112, this is also three wave functions having the same energy value. This is the 9a square, 8a square. This is also threefold degenerate. And whenever we are going to the next hard energy state, psi 222, this is the wave function, and energy of this level is 12 square divided by 8 square. So this is non-degenerate. So it is seen from this table that whenever this nx, ny, nz all are three equal, here and here the level becomes non-degenerate. But whenever any one of the quantum number differs, then the degeneracy also happens. And now I shall give some three problems to calculate. Calculate the number of energy degeneracy for of the particle level of the energy level 14 square divided by 8 square for a particle in a cube with zero potential energy. We know that nx square plus ny square plus nz square, a square divided by 8 square is the total energy, and this is here 14 square divided by 8 square. So actually nx square plus ny square plus nz square equal to 14. So the combinations of nx, ny, nz, there will be six combinations. It will be nx, ny, nz 1, 2, 3 or 1, 3, 2 or 1, 2, 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2 and 3, 2, 1. So 1, 2, 3, 4, 5, 6. The number of degeneracy for this level is 6. Another problem, determine the degree of degeneracy of the level 38 square by 8 m square for a particle in a cubical box with potential energy 0. So the number of degeneracy, degree of degeneracy will be equal to total 9. We can say this 34 n square x square n x square plus n y square plus n z square equal to 36, and 36 could be obtained by putting one quantum number 2, another quantum number 3, another quantum number 5. So 2, 3, 5, you can write 2, 5, 3, and then another wave function containing 3, 2, 5, and this is 3, 5, 2, and 523 and 532. So in this case, whenever we are taking this one nx value, 2 another nx ny value, or quantum numbers, 3 quantum numbers, so 2, 3, 5, then it will be 6-fold. And again, this combination may also happen 1, 1, 6, 1, 6, 1, and 6, 1, 1. This is a 3-fold. Total 6 and 3, total 9-fold degenerate. This level will be. Another the problem 3. If a benzene is regarded, this is like the spectra of this benzene, which wavelength of this benzene will be absorbed, and this value of this wavelength would be determined by means of the spectrophotometer instrument, which is a very useful instrument to determine correctly the frequency wavelength of this molecule. So this by this simple model, if a benzene is regarded as square box of site 0.4 nm containing 6 pi electrons, in a benzene there are 6 pi electrons, then calculate the wavelength to promote the pi electron to the first excited state. Here the energy levels are written in this way. This is E11 and 2h square divided by 8 ml square. This is the ground energy level, lowest energy level, 0 point energy, and for next state it will be 1 E12 and E21, both are having the same energy, and this may be taken as this wave function psi 1 2, and this is psi 2 1, and in this case psi 1 1, and in this case psi 2 2. So this is a double degenerate. Two states are there for this level, and here 2 electrons, here 2 electrons remaining in pair, and this is the HOMO, highest occupied molecular orbital, and the electron will transit from this HOMO to LUMO, lowest unoccupied molecular orbital, whose energy is E22 equal to 8 square divided by 8 L square. So delta E, the difference of these two, LUMO to HOMO, equal to 8h square divided by 8 ml square minus 5h square divided by 8 ml square equal to 3h square divided by 8 ml square. So delta E, this energy to be obtained by this molecule by absorption of one photon, and this photon having the energy h nu, and this is h by lambda c, velocity of light in vacuum, lambda the wavelength of this radiation to be absorbed, or this benzene to promote from this HOMO to LUMO. So hc by lambda equal to 3h square divided by 8 ml square. So lambda equal to 8 ml square c divided by 3h. And n is the mass of this electron, 9.1 into 10 to the power minus 31 kg, and L here 0.4 into 10 to the power minus 9 meter, and c the velocity of light, it is 3 into 10 to the power 8 meter per second, and h is the 6.626 into 10 to the power minus 34 joule second. If we put all these values here from right hand side, then lambda would be found to be 176 nm. Means this is the wavelength of this benzene will be absorbed for this excitation. This is all about the particle in 3D box. First I shall discuss the rectangular box, then how the rectangular box is converted into the cubical box, and whenever we are discussing this cubical box, one interesting the phenomena comes up. This is called the degeneracy, and degeneracy are shown for this particle moving in a cubical box. However, the degeneracy could be lifted if the length of any one side will be slightly distorted. Then this is the energy levels, and I have also set the 3 problems, and I have done all these problems, and you are requested to do more problems as an exercise to make to have more confidence. And now let me thank you all who are watching this video.